Alright guys, so today we're starting 7.3. This is 3D drawings from different perspectives, and there's two basic types of drawings that we need to know. The first one is an isometric drawing. An isometric drawing shows a corner view, of an object, in which the shape of the object is preserved. In which the shape of an object is preserved. Now, essentially what you need to know, that's kind of the tough definition. It's basically a 3D figure, like the one you looked before. This figure number 1 is an isometric view. It's showing the corner view of a 3D figure. Now, orthographic drawings show a straight-on view of an object. Show a straight-on view of an object. What this is actually is a 2D representation of a 3D figure. Like when you look at a 3D figure from the front, straight up from the top, left to right, you see 2D figures. In our case, we're going to see squares. So let's look what an orthographic drawing looks like. When we do orthographic, it's 2D representations of that 3D figure right above from different sides. So the first one wants to know, what would it look like if I looked at that straight from the top? Well, the top of that, guys, is just 4 squares. If you're looking at that figure from directly on top, that's what it looks like. Now let's look at it from the left, which will be this side. Well, if I look at it from the left, I'm only going to see 2 boxes. Now you can't see the right side over here, but you should be able to infer what it looks like. It should look exactly like the left side. And then from the front, kind of looks like from the left and right. It's 2 blocks. Now the left, right, and front won't always look exactly the same, but think about that figure. If you rotated it to that perspective, what would it look like? Let's go ahead and go to the next page. Here is our orthographic or isometric view. We need to make the orthographic views from the top, left, front, and right. I would like to pause for a second. Everybody try to draw those figures. If I look at this from the top, guys, these are all the tops of the cubes. Now, it may seem like we would see more than that, like more than the first one, but all we're going to see again is the 4 squares. Now, let's look at it from the left. Well, I'm going to have 2 squares that show me the bottom, but then I'm also going to be able to see that other shaded square on top, so I put a square on top of it. The front view is going to look very similar. I'm putting F's on all the ones we'd see from the front. It looks a little bit like it did from the left. I'm going to have 2 blocks on the bottom and 1 on top. And then we have to do the right side. Guys, the right and left side views are reflections of each other, so it's going to look like this. So use your imagination, guys. Imagine what would happen if you turned it and looked at it. Let's try another one. Again, let's pause for just a second and let's see what we can do. So first it needs it from the right side, which is going to be over here from this perspective. So the right side, it kind of looks like it's going to be a ladder going up. So I'm going to start with 1 block, and the next one's going to have 2, and the last one's going to have 3. From the top view, you may think it's not going to be just 6 squares, but just mark the tops. These are all the tops. That's all I'm going to see. So it's going to look like 6 squares. And then the last one is from the front, and that's going to look almost exactly like the top. We're going to see these blocks right here. So again, it looks a lot like the top. It's just 6 squares. So there's one other thing we need to look at with these, and that's how many cubes make up a figure. Look at the number 2 cubes real quick, and I want you to write down how many cubes make up the figure representing that isometric drawing. It looks like there's 4 on the bottom. Even though we can't see it, we imagine things can't be floating in air. And then plus the one on top will give us 5 blocks. Try to find how many blocks will be in the figure on number 3. Now, I know for sure I can see 2 blocks on top, but those 2 blocks are on top of 2 other blocks, and then I add 2 more blocks to that. So now I'm at 6, and the bottom one has 6 blocks also. That leaves me 12. The figures cannot float in midair, and you have to fill all the spaces. Let's go to the last page. Now we're going to talk about nets. A net is a two-dimensional drawing, or 2D drawing of a 3D object. Essentially what you've got is if you have a 3D object and you cut it apart and laid it down flat, that is a net. So let me draw you a cube real quick because that's the first one we're going to start with. A cube's going to look like this, and I need the net of a cube, so I want to think what it would look like if I broke it apart. An easy way to do that would be looking at how many sides it has. A cube has 6 sides, all of them are squares, so my net has to have 6 squares. But there's a lot of different ways that don't work with 6 squares. A base way that always works is 4 down the middle, and then 1 square on one side, 1 square on the other. Think about rolling this side up, and then these 2 pieces on the end would close the cube off. A lot of people like to draw them like this, with 5 cubes, and then 1 on the outside, or squares, and then 1 on the outside, but there's no way that would fold up, because if I did, this would overlap that, and nothing would close this side of the box. Let's look at number 6. This is a net. I want you to try to figure out what shape would be formed. Now, I realize y'all haven't talked about prisms or polygons much, but basically, if you fold this one up, the main shape that's inside of it when you fold it up will be the first part of the name, and then prism will be the back. So if I folded this one up, it looks like I'd have rectangles on all the sides, and then I would close it up with these longer rectangles that are going to be the sides. So we're going to call this, you could call it a box, but more specifically, it's a rectangular prism. Whoops, messed up my P there. Sorry my handwriting's so bad on this one today, guys. Wasn't really working out well. So rectangular prism, guys, is 2 rectangles that are connected by the lines in between them. If you want to see, it would be like here's a rectangle, and now we're talking about connecting them together. So these main things, the top and the bottom, are like the main rectangles. All the other ones are like the sides. So guys, do your best on the homework. This is not a very hard one. If you have trouble with the nets, because that's kind of where it gets a little fuzzy, you might get on the internet and look it up. There's tons of easy net things on there. So do your best. If you have troubles, I'll be back tomorrow. Good luck.